And today we will carry on this subject with some examples elaborating the mathematical background required for this one. I'll just refresh your knowledge about this mathematical background. So the first thing you must know is the difference between the physical quantities. Physical quantities are of two types. One is called scalar, and the second one is called vector. So the scalar quantity, a quantity defined only by magnitude, so only by magnitude, like pressure, temperature, and density. Okay, vector is a quantity defined by magnitude and direction. So now the difference is like this. If I have, for example, scalar quantity like a pressure, so it is enough to say the pressure is 30 MPa, 30 megapascal. So it is enough to describe the pressure. The same thing for temperature. Maybe I'll say it is 10 Celsius. So that's enough. Now, come to vector quantity. Vector quantity, for example, we have vector quantities like force. When I have a force like this, it is 100 kilonewton. If I say this force is equal 100 kilonewton, this description is not enough for this physical quantity. Why? Because I also need to know the direction, because different direction will give different effects for this force. That's why force is a vector. But temperature, pressure is the same thing for velocity. Velocity is a vector. You study this material in the first and second year of your study. Now I just refresh your background. So with scalar there is an associated scalar field, and with vector there is a vector field. We will explain these fully as we go through our course. Now, vectors. What's the meaning of vector? Vector is defined like this one. You see, here it is V. V is a vector. Vector is defined by a symbol, this letter V, with an arrow above. So this is the definition of vector. You see, I is also vectors. I, J, K are also vectors. So each vector in space is described by three components. One is V sub x, the second is V sub y, and the third is V sub z. Okay, where V sub x, it depends on x, y, z, and t. X, y, z are the Cartesian coordinates. It is like this, x, y, and z. And with each component, or with each direction, with x, we have I. And y will be with, j will be with y. While k will be related to z. So I have I, j, k. So these are vx, vy, vz. So the full description of V is described by these three components in space for its location, for its position, and there is another variable which is the time t. Okay, now I'll go through the first important operation which is done with vectors. I remind you of this, what is called, you see, we have an operation here. It is I dot I. Now I dot I, this is called dot product. Dot product. So because I will have another type of product which is called a cross product. I guessed many of you remember this one. So I am now discussing dot product. Dot product, and it is designated by this dot. So it is I dot I and J dot J, K dot K, and so on. So given two vectors, A, now if I have, you see, these are the unit vectors. You must know these operations, dot product. So any I dot I, J dot J, K dot K, the result is 1. And if these dot, if any two different, you see, I, J, they are different. J, K, they are different. I, K, they are different. If dot products are of two different unit vectors, the result is 0. Here, I dot I, you see, I dot I, so they are similar. I, J, J, K, K, the result is 1. Now, I discuss a more general case in which I have A and B. You see, A, the vector A, all these are vectors, but here you see, A sub x, it is not a vector, this is a quantity. I is a vector. Maybe I can give an example. A, this is a vector, equals A sub x, it is A sub x 3, for example. I, it is something like this, 4j, and minus 5 minus 8k. So these are the component. Here there is a misprint, typo, it is y, it must be y. This is also must be y. So you see, here ax is a 3, ay, for example, this one. So these ax, ay, az are all scalar but multiplied by a vector. So scalar multiplied by a vector, it will be a vector. So if I have a vector dot b vector, and I have these three components for each of them, then a dot a equals ax multiplied by bx, ay multiplied by by, az multiplied by az. I'll now go through a numerical example to explain more about this one, so as it will be easier for you to understand through numerical example. Let's go.